Hi everybody, this is lesson 5.5. The title of the lesson is How Fast? Let's read the specific objectives. Students will understand the different exponential growth rates. Students will be able to write specific population growth models from general exponential growth formula, compare population growth of two countries, predict population using the derived models, and display the exponential growth models on a rectangular coordinate plane. Alrighty, so we will continue looking at exponential models in this lesson, which were introduced in the previous lesson. So let's go ahead and read the first problem situation, population growth. So populations of people usually change over time, therefore population change can be modeled. Why would you want to create quantitative model for population change? In other words, why might it be important to predict the future population of a city, state, or nation? I'll give you a moment. Well, of course, we want to know what will be projected population be in future, so we can allocate the resources, decide on infrastructure or anything that needs to be created, built, expanded, and things like that, right? So we want to know how much resources and money to allocate to a given city, state, or as a country, of course. All right, so now let's talk about population growth. So here I found the two towns in New York State. One is small town of Clare. It has a population of about 100 people. All right, so if you think about it, what do you think in terms of number of babies that will be born in that year? Just, as a prediction. We don't know anything about the town, but if you had to give a guess, what would you say? All right, well, I would say maybe like 2 babies, 3, but it will be in single digits, right? I mean, because we have 100 people, so maybe one couple might have a baby, and that's it, right? Maybe 2, but I would say 1 to 3, correct? Maybe even 0. But we're not going to say 10, 20. That wouldn't make sense. All right. Now I found another town by the name of Avoca. It has about 1,000 people. So what would you say there will be? And by the way, I apologize here for the mistake for the towns. I forgot to correct that. So what would be the population in the next year in that city of Avoca if you have 1,000 people? Then what would you think? Let me give you a moment. How many babies will there be? All right, well, here, since it's 1,000, maybe instead of just single digits, we might have double digits because we have a bigger population. All right, so maybe for every 100 people, you're going to have one couple that will have a baby. And we have, what is 1,000? It's 10 hundreds, correct? So I don't know, again, maybe 10 to 30 at most. All right, again, it's just hypothetically speaking, looking at the population size. The point of this is to say that looking at those examples, what would you say the conclusion would be in terms of the number of babies that will be born? What will it depend on? All right, so what would be a general conclusion about how population change relate to any given population? I'll give you a moment. Well, the idea here is that the amount of people that you expect the population to grow will depend on population size to begin with, correct? The larger the population, the more people you expect to be, by more people you expect it to grow, right? Now, this idea of a relative change was discussed much early in the course. So the relative change or relative amount, the word relative, does it refer to what? I'll give you a moment. Well, it is referred to as a percent. Percent represent relative change, right? So for instance, for these two, I can say, well, it's 1 to 3% would be the number of expected growth, right? 1 to 3 people. But notice that 10 and 30 out of 1,000 is also 1 to 3%. It's the same range. Why the number is bigger? Well, the population is bigger. 1% of 1,000 gives us exactly 10. Right? And if the population was, instead of 1,000, 10,000, that's a bigger town, all right, then you will expect to be maybe 1% of that, which will be not 10, but 100. You understand? The larger the population, even if it's the same percent, you will have a larger growth. The absolute growth will be higher. All right, so now when we talk about percentages, right, when we're talking about percentages and we'd like to model it, based on the prior lesson, right, we already covered linear model and exponential models. All right, if we're talking about percentage and the percentage growth, think of the previous lesson. What model would you use? Linear model or exponential model? I'll give you a moment. When we talk about percentages, we talk about exponential growth. All right, just like we talk about money in the CD or depreciation. Well, depreciation is going down. We're talking about appreciation, meaning going up. If something is going up, subject to a percent, that means that the larger amount that you get and you apply the same percent, it's going to become even larger. So the change each year is not the same. It's always a little bit bigger. And that's what we're going to explore right now when we talk about populations. All right, so we're going to look at one of the fastest growing countries in the world. It's Ethiopia. It is the second most populous nation on the African continent, and its population was about 115 million in the year 2020. And the rate at which it's increasing is 2.5%. That means yearly. It says per year. Now we'll assume, for the sake of this problem, or for the sake of this situation, that the population will continue growing at that same rate, and therefore it will follow the exponential growth. Just a little disclaimer, when it comes to percent rate, when it comes to population, it's not the same as when we talk about money. With the money, you can have a fixed rate. With the population, there are more variables involved. So there's a certain time in history when the population rate is going to be, let's say, 2.5% for Ethiopia, but there were periods of time when it was smaller. It might become smaller, all right, or it can become bigger. All right, there are a variety of factors that influence it. A lot of times it's economical factors. All right, but we will explore this for the sake of understanding the percentage growth. All right, so here you're given an exponential form that you have seen in the previous lesson when it came with money. Remember that form where you had A equals to, you start with the principal, and then it is 1 plus the rate multiplied by the time? So that's going to be the same formula. We're just going to change things because we're not talking about the money. So the B is the letter that would represent the starting amount. R is the rate, but it's going to be expressed as a decimal. And T would be the time, which will be represented in the years, how many years passes by. So here we're going to create a mathematical model for how the population will grow in Ethiopia over the time, where we're going to say E would be the population. Notice we're not going to write numbers in expanded form. We're just going to use millions. All right, so we're going to be using millions. Let me highlight this. And the number of years is going to be counted not from the beginning of time, so whatever, it's going to count it from the year 2020. The initial information for which is provided to us, right? We know the population is going to be then. Alrighty, it says use the variable defined above to create an exponential model predicting the population of Ethiopia over time. Alright, so connect what's highlighted right here, the percentage, the amount that you start with, your equation for the exponential growth, and I'll give you a moment to write down your model. Go ahead. Alright, so let's review. So the model here is the population of Ethiopia is going to be the starting population, 115 million. We're not going to write it in expanded form, just leave it in millions. And it's going to be 1 plus the rate. Now, be very careful with the rates. Be very careful with the percent. So the percent of 2.5 means very careful. Okay, that's a very common trap, is you got to divide it by 100, so it's going to become this. Okay, Not 0.25, but 0.025. Be careful when you're converting. All right, so then we're going to attach it to 1 to give us the growth factor. And then we put an exponent on top, which represents the time. And then the time is going to be starting from the year 2020. You see it? Okay, we can write it up and we can simplify this. You can definitely add 1 with the rate. Okay, and you know already that I really annoy you about recognizing this as being a growth factor, like the thing that you do things in one step. All right, so again, I'll keep doing this until our last lesson, is that when you are increasing in the by a specific percent, attaching that 1 will make it grow by a factor. So when you multiply by that number, you get the next population, the next year. And if you keep doing it, that's when you have an exponent that you could attach. All right. All right, so now let's look at the other country, particularly our country, the United States. It has a population of 330 million, or it had a population of 330 million in the year 2020. And the US is growing at the rate of 0.7% annually. It has been fluctuating somewhat, so it changes, right? But it is lower than, it has been lower than 1% for at least in 2010s, in the last decade or so. All right, but again, for the purposes of mathematical model, we'll continue building it based on this rate, and we'll assume that that rate will continue in future. All right, so question 7 here. If the US and Ethiopia continue to grow at the given rates, will the population of Ethiopia ever catch up to the population of the United States? If so, how long do you predict that it will take? All right, so guys, here the question doesn't ask us to say exactly what that, whether in what year it will happen. We'll explore this, but just by looking at the rates, right? So Ethiopia has a rate of 2.5% growth, but it starts off with 115 million, while the United States has a growth of 0.7%, and it starts off at a larger population of 330 million. All right, so will Ethiopia catch up? What do you think? Just yes or no question. And if yes, then in what year? Again, your prediction. I'll leave it not as multiple choice, but as open response question. All right. All right, I'm not gonna go over this now because we'll see it. The only thing I could say is that the rate of 2.5% is much higher than the rate of 0.7%. And this is Ethiopia, and this is the US. So the Ethiopia has a much higher rate. If you compare them, relatively speaking, it would be Ethiopia is growing at 4 times, or about 4 times the rate of the United States. So it will catch up. It will catch up if the trend continues, of this percentage stays. All right, so let's go. Let's do this. It says define a variable representing the population of the US and create an exponential model that will predict the population of the US over time. What I'm going to do is I'll just use the same variables that were defined earlier the same way. So we're going to use U for the population of the US in millions, of the United States in millions. And then we're going to define T, just like we did it before, right here. Time, the number of years, starting in 2020. So number of years, let me pull it up, number of years since 2020, or past since 2020. And I'm going to ask you to write the equation. All right, so I'll reminding you some numbers. So we had 330 million in 2020. All right, and the rate of growth is 0.7%. So go ahead and write the equation. And again, be careful when you're converting rate into decimal. 0.7% is not the same as 70%. That would be insane if the rate was that high. All right, it's 0.7%. So it's less than 1%. So go ahead, write the equation. All right, let's review. So the population of the US is the starting population, and then 1 plus the rate to the power of t, and the rate is point, move 2 places, 0, 0, 7. All right, 2 places from here, 1, 2, 0.007. All right, if you only move 1 place, it will be 7%, and it's not 7%, it's not 70%, it's only 0.7%. So that's going to be our model. You can put them together, attach one to it, but here it goes. It says use the model you created for the population of the two countries to fill out the table below, round your answers to the nearest million. So here's how we're going to do this. So I'm going to write the equations for you for convenience purposes, so we can just look at them as we go. So the Ethiopia was, I believe, 115, right? 115. And then it is growing at 2.5%. And the US is right here. It's 330, and it's growing at 0.7%. Okay, let's make sure we copied everything right. Okay, very good. Notice when you look at the year since 2020, all the time is from 2020. So when the time is 0 from 2020, that means it's a year 2020. When you substitute 0 in both of these equations, anything to the 0 power is 1. So that gives us the starting amount. See, anything to the 0 power is represented as the starting point. So it's 1. 1 times 115 would be 115. So we have 115 right here. We have 330 right here. And then here's what we're going to do. I'll just ask you to calculate, let's say, what would the population be in 15 years for both of the countries. And then we'll review. And the rest, I'll put it in Excel, so then we can graph the two models together on Excel. Alrighty, so I'll give you a moment. Find a population of Ethiopia after 15 years, and find a population of the US after 15 years. Go ahead. All right, let's review. So as always, I'm bringing decimals so you could see how you enter the numbers neatly. So let's do this. So for Ethiopia, it's 115. All right, times. You can use parentheses, but you don't have to, since it's all it will follow the order of operation. So you put the exponent and you put 15 years. So the population is going to be about, and let's round it to one place. So 166.6. All right, so that would be population of Ethiopia. And then similarly, let's do the US. So it's, let me move it this way so you could see it. So we have 330 times, oh, let me move it up so you can see the screen here. So 1.007 to the power of 15. So the US is going to have 366.4. All right, notice that the US still has a higher population after 15 years from 2020. So that will be the year 2035. All right, so the rest we're going to do on Excel, and I'll put it for you here. And if you're interested in learning it, then you definitely could follow what I'm doing right here. But for our class, what you are expected to be able to do is to do this on a calculator. So the Excel will not be tested. All right. However, as I think I mentioned before, Excel is a very common software that's used almost everywhere in very different disciplines that involves with numbers. Numbers are everywhere, as you could see from this course. All right. So let's do this. So we got 0, You know what? I'm gonna go by 10 years instead of 15 years. All right, and I'm gonna go all the way up to, let's say, 100 years from 2020, so the whole century. All right, and then this will be the time, and then I have the population of Ethiopia, and I have a population of the US. And the way I'm going to do it, I'm going to enter the formula that we developed, which is our equation for each one of them. So the population of Ethiopia started with 115, and then we multiplied by 1.025 to the power of number of years that pass. You see what I'm doing? Starting with the equal sign and just selecting what the exponent is. Right here, I'm entering the formula, and then you can either drag it or you can double click. All right, you can also choose the number of zeros so it doesn't kind of bother our eyes in so many digits. So all of this in millions. Okay, so that would be the Ethiopia. And for the US, we have 330, and it's growing at the rate of 1.007, which is 0.7% to the power of the number of years. All right, so, and then we double click. Let's also make this have less digits. Oops, like that. And then we'll look at this chart, and you could see that eventually the Ethiopia overtakes the United States. So that happens somewhere around here, around 60 years, I guess, right? A little less. But let's follow and see the prompts. So I'm skipping this. All right, so you should be able to calculate this. You have this Excel also output, so you could see that. Graph. All right, so let's go ahead and graph this thing. Okay, so as we have seen in past lesson, whenever you have an exponent, right, it means that the model is not linear. So in other words, it's not going to have a constant rate of change. So if you go from one number to another, the difference between the two numbers, the difference between them is not the same. It's getting larger, larger, and larger. Check this out, especially look at the Ethiopia towards kind of the end here. So like after 80 years and the 90 years, the difference here is about 240 million. Well, the difference here is almost 300 million. So the difference between those two numbers is becoming larger, larger, and larger. And it's true for the Ethiopia, and it's also true to the US. Check this out. Here the difference is about 36, while here the difference is almost 40. Okay? Now, and you can see that the rate of Ethiopia, because it's 2.5%, making the increase even more significant. This will be even more clear once we take this and we graph it. All right, so I'm going to insert a scatter like this. I'm going to use the layout to make it more mathematical. All right, like this. And then let's see if I can connect this points. I guess I'm looking to see if I know there's one that's connecting them. All right, I'm going to make this myself. So I'm going to edit an exponential trend line so we can nicely see you know, the picture. All right, and let me take this and let me put that in OneNote so then we can analyze this. All right, so let me put this in here, paste. Let's see if I can move it. One moment. Here we go, I managed to move it. So let's change the title. So that would be years since 2020. All right, this will be right here. Population in millions. Population in millions. And notice, you see, they both not lines. US appears more linear just because it has such a low rate. But Ethiopia definitely does not appear linear here. You can see that it is curvy. And that tells us that the rate of change, so basically the slope, if we calculate the rise over run, it's just getting bigger, 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 and bigger. Alrighty. So now we can say when, now you can see at the picture that in about 60 years, Ethiopia will overtake the United States. So that year would be 60 from 2020, 2080. All right, based on that rate, if the rate goes to continue. But we got to be a little bit careful about making conclusions like this. The model is usually good for a narrow period of time. When something is going for such a long thing like a century, it's just not a good predictor. All right. So within a decade, it is. All right, because if you look back at the 20th century, 1900s, then the United States started off with a very high growth rate, and then it slowed down. So, and there are also wars and other factors. So, we can't take the model as being the definitive thing that will happen, but it's a good predictor of what could happen. And for our class, it's also a way to see how different descriptions that happen in real life, percent change, can be modeled using mathematical tools like equations and graphs. And on that, we're going to finish this lesson.